In this part 6 video of binary classification machine learning using bank marketing dataset, we are going to define a function that is reusable evaluation function for every single machine learning models that we are going to train. As we know that our dataset has imbalance problem. Labels are not equally distributed. So in that case, it is really important that we evaluate the models from every single action. Accuracy alone might not be the best way to evaluate the model's performance. So we would like to use the precision, recall, F1 score, ROC-AUC score, and overall confusion matrix, and also the classification report, so that we have the very clear picture about model's performances. Let's look at how does the function look like to intensively evaluate the model's performances. Let's define a function called evaluate classification model. We'll feed the model, that's going to be the model that we want to evaluate, and xtrain, the training features, ytrain, training label that we will give this data set to the model to learn from. Then we have a x-test and y-test, the test features that we will give the model to predict on, and then y-test, the labels that model will never see, but we will use that y-test, the test target, to see how well model's performance aligns when it predicts on the x-test. Then model name is going to be the model that we will be evaluating on. And here, the same parameters that we have defined over here. Then we will return the dictionary that contains all evaluation matrices. So to begin with, we will begin with predicting on the xtrain. First of all, we want to see how well the model does on the training features. Then we will also do the predictions on the x-test. So here for xtrain, model already sees the train target. And then for the x-test, model never sees the test target. We'll use that to evaluate so that we will be able to know if model has overfit problem or not. Then next comes is using the predicting the probabilities for the positive class if it is available. Then we'll use the trend proba and the test proba. We'll get the probabilities of the predictions. If not, we'll just leave that as none. Then we have the results that we want to calculate on those training and predictions. Beginning with, we'll give the model name, which model we want to evaluate on. Then training accuracy. We want to get the accuracy score on the training set. So we want to use the ytrain, the training labels, and then the predictions that model has done on the training features. We'll compare how well they are aligned. Then same way for the testing set. So we will give the model X test data, and we would like to ask the model to predict the labels for those, and we'll compare that with the Y test. Then we want to also get the test precision, how well the model does on catching all of those positive or negative classes. Then recall as well. We want to see out of all positive or negative class, how many of those model is able to capture. Then F1 score, the harmonic mean of precision and recall. Then we want to also get the ROC-AUC score of those performances. So this way, we will be able to evaluate the model's performance intensively from every single action or every single angles. So we will store that all the results into results dictionary. Then we will be using that later to print and then display all the results. Here we want to print all the results we have got from above calculation right over here, rounding up with the 4 decimals. We'll use the model name and all the evaluation matrices. Then we will construct a classification report that will give us the complete picture about how well model does from precision, recall, and then sample size, how much of the data was used on each classes, etc. Then we'll print a confusion matrix. That's one of the robust way of understanding the true positive, true negative, false negative, and getting overall picture about the model's performance using confusion matrix. Then we'll display the confusion matrix using the Seaborn heat map so that we have a nicer representation of those confusion matrix output. Then here we would like to get, if we have the test probabilities, then we want to display ROC curve as well, and we want to get also precision recall curve. We get the more better picture of the model's performance. Then we will return at the end, we'll return the results that we have calculated right here. So that is the ultimate objective. So basically, using this function that we are defining, the evaluation classification model will be able to get understanding of the model's performance from every single angle so that we are fairly and accurately evaluating the model's performance. This was a quick walkthrough of the function that we have defined. And next one, we're going to begin with model training. And that's going to be the very first model, logistic regression. Please do not forget to check my next video in this binary classification model on the bank marketing data set, the series of the videos that I have made, so that it's going to be complete tutorial for you to understand how end-to-end life cycle of any machine learning project look like. So please do not forget to check that. Also, if you have not yet subscribed to my YouTube channel, please do subscribe and hit that like button for this video. And until the next video, please enjoy learning. Thank you for watching.